Hello everyone. This video is under Innovation Hub of DBT Star College and VIPNet Club of Kanya Mahavidyalaya Jalandhar. In this video, I Vibhuti Salaria will be explaining an experiment based on Doppler effect. Have you ever heard an ambulance or fire engine pass and heard the siren change suddenly? Let us look at an example. Based on many observations, an Australian physicist and mathematician J.C. Doppler proposed the Doppler effect in 1842. According to him, the Doppler effect is the shift in frequency and wavelength of waves which are emitted from the source moving with respect to the medium, or a receiver moving with respect to the medium, or even a moving medium. It's very easy to notice this effect. You could notice how the pitch of siren increases when an ambulance gets close to you and how it decreases when the ambulance gets far away from you. First, let's understand how waves propagates from an emitter. Notice they propagate equally in every direction. The frequency of this wave is determined by how many times these circles or waves pass through one point in 1 second. If 10 circles pass through one point in 1 second, the frequency is 10 Hz. But if 10 circles passing 2 seconds, the frequency is 5 Hz. The higher the frequency, the higher the pitch, and vice versa. Let's see what happens when the ambulance starts moving. Note, the waves present at front are close to each other and at the back are far from each other. Clearly, at the front, the frequency has increased as the ambulance is moving forward. The newer waves are generated further ahead. So, if the siren is moving towards you and the wavelength of the sound heard by the listener shortens, therefore you will hear a high pitch. For the same reason, when a person is at back, the frequency has decreased and the wavelength of sound heard by the listener will be long. Therefore, you will hear a low pitch. Now let us move to our experiment. The apparatus of this experiment consists of a buzzer and battery attached to the upper scale. We also have movable masses attached to the scales. Now when the buzzer is switched on, the sound waves will be emitted from it. The frequency of sound waves near the buzzer will be greater than the frequency far away from it. Therefore, when the mass is away in a low frequency zone, the pitch of sound will be low. But as the mass is brought closer to the buzzer, the frequency increases and the corresponding wavelength decreases. Therefore, there is increase in pitch. So, let us perform the experiment now.
Hence, as the frequency increases, there will be an increase in the pitch. Now, we will see what happens when we move the upper scale. This means that now the source will be in motion. So, as the source moves closer to the observer, there is an increase in frequency, and when the source moves away from the observer, there is a decrease in frequency. Hence, the frequency increases and decreases. Hence, there will be change in frequency of sound due to the motion of source. Now we will see what is the use of lower scale. Here, due to the coupling effect, same phenomena can be seen. That is, when the mass is moving towards the source, there will be increase in frequency, and when the mass moves away, that means when the observer moves away from the source, there will be a decrease in frequency. In the same way, when the scale is moving in to and from motion, there will also be a change in frequency. Thanks for watching this video. I hope you liked it.